In this question from the chapter waves, we are having a stationary listener in between two identical tuning forks which produces sound of frequency 1400 Hz, and one tuning fork is approaching the listener and the other is moving away from the listener. It is given that the stationary listener hears 2 beats per second. Now, beats arises when two nearly equal frequencies are sounded together in a medium, and this happens when the resultant intensity periodically rises and falls. Since tuning fork is approaching the stationary listener in the first case, we have a Doppler effect there. And again we have Doppler effect due to the tuning forks, the second tuning fork moving away, that is receding from the stationary listener. So the both frequencies are different, which will be nearly the same as 1400 Hz, the actual frequency. One will be higher and the other will be lower because one is approaching and the other is receding. So the general formula for the Doppler effect is that the apparent frequency as heard by the listener is equal to the actual frequency as produced by the source multiplied by velocity of sound in the medium minus velocity of the listener divided by velocity of the sound again minus velocity of the source. So nu dash is equal to nu into V minus VL divided by V minus Vs gives the apparent frequency of sound as heard by the listener in the Doppler effect. Now we have to apply the sign convention in this formula to find the exact apparent frequency. The sign convention is that the direction in which the sound travels so as to reach the listener will be taken as positive and all the other values will be taken as negative, means the opposite direction values will be taken as negative. In the first case, the source is approaching the stationary listener. So listener is stationary, so VL is 0. The source is moving in the direction of the sound, so the velocity of source is positive, so there is no sign change here, V minus plus Vs. So the apparent frequency 1 will be equal to the actual frequency multiplied by V divided by the listener is stationary, so VL is 0, V divided by V minus plus Vs as the velocity of source is positive. This is one of the frequency heard by the stationary listener. And the next tuning fork is moving away from the listener, so it is receding. So the sound travels in a direction, so towards the left in this case, so that the source is moving towards the right, so the velocity of source is negative from the sign convention. So it will be a frequency given by again nu multiplied by V. VL is 0 as the listener is stationary divided by V minus of minus Vs, which is V plus Vs. So the source velocity is negative. So the formula changes like this. Now these are the two frequencies. Even the original frequency as produced by the tuning fork, which are identical, are equal, and due to the Doppler shift, the two different frequencies are these two. And it is given that the listener hears 2 beats per second, that is beat frequency is 2. So the difference in these two frequencies will be equal to 2. We have to calculate the speed of the tuning forks approximately. So given that velocity of sound in the medium is 350 meter per second, so substituting the actual frequency 1400 in these two positions and 350 meter per second at these 4 positions, and substituting we will get the value of Vs. So 1400, 350 multiplied by 1400 can be taken common and solved, so that we get Vs is equal to 1 by 4 meter per second, which is option 1. An electron and a photon have the same kinetic energy. We have to find the ratio of the wavelength of electron to that of the wavelength of the photon, given that the mass of electron is m. The wavelength of electron can be obtained from the concept of matter waves, which is lambda is equal to h over p. Given that energy is E, so the kinetic energy of the electron is p square by 2m. So we have lambda is equal to h by root of 2me. So the momentum in terms of the kinetic energy is given as root of 2me. So the wavelength of electron is given by h over square root of 2me. Photons have zero rest mass. So from Planck's quantum theory, E is equal to h nu, where nu is the frequency and h is a Planck's constant, and nu is c over lambda. So from this, lambda is equal to hc over E. Therefore, the ratio of wavelength of electron to that of photon is given by h over root of 2me divided by hc over E, which is 1 by c times root of E over 2m. The answer is option 4. In this question, we have to find the potential difference across the points A and B. We are having three resistances, 10 ohm each, a PN junction diode, and a driving voltage source 30 volt. Since the PN junction diode is forward biased from the circuit, it acts as a connection wire, so that we have the two 10 ohm resistances parallel to each other, which is in series with the 10 ohm resistances and is connected to the voltage source 30 volt cell. So the two 10 ohm resistances in parallel across AB will yield an effective resistance of 5 ohm. So the potential difference across AB is given by the current flowing through AB multiplied by the effective resistance across AB. The current can be calculated by the ratio of the potential difference or the effective EMF divided by the effective resistance. So the two 10 ohm in parallel yields an effective resistance of 5 ohm, which is in series with this 10 ohm resistance. So the total resistance will be 15 ohm, so that the current flowing through the circuit, the main current through the circuit will be equal to the net EMF, that is 30 volt, divided by 15, which is 2 ampere, multiplied by resistance across AB, which is 5 ohm. So the answer is 10 volt, which is option 3. In this question, we have to calculate the dimensional formula for B square divided by 2 mu naught, where B is the magnetic field and mu naught is the absolute permeability. Now, this question is very simple one if we have the right approach, because this is the formula for energy density of magnetic field. So we have half epsilon naught E square as the energy density of electric field and B square by 2 mu naught as the energy density of magnetic field. So energy density is energy per unit volume. So energy is having the same dimension as force times displacement, because energy is having the same dimension as work done. So force times displacement divided by volume is the basic formula which we will use to obtain the dimensional formula for the magnetic field's energy density. So this is force is mass times acceleration, which is ml t raised to minus 2 multiplied by displacement is L divided by volume is L cube. So we have m, L square by L cube is L raised to minus 1, t raised to minus 2. The answer is option 2.